this session, and I will send a link to you as to where to see this recording. It might be tomorrow morning. I kind of guarantee it by tomorrow morning. Occasionally I can get it out the same day, but not always. Depends on how many sessions I have in that day.
Sounds good.
Now, I'm going to my email. Tell me, are you sending something?
Yeah, I can.
Okay. Go ahead and tell me when it says email sent. What kind of phone are you using? Is it an iPhone?
Mm-hmm.
Make sure you send it as a large image or actual size. One or the other. Don't send it as a small image. I won't be able to read it.
Okay. It's sent.
Okay, cool. Let's have a look. Make sure I can see it. Or have received it. I got it. You're seeing my screen, right?
Mm-hmm.
Okay, I'm going to have to download that so that I can rotate it. And also zoom in on it. Well, my rotate didn't. Oh, there it goes. Just slow. All right. Which of these problems do you want to look at?
61
All right.
and 62.
61 and 62. Okay. The single pane of glass obliterates 3% of the light, then the percent P of light that passes through in successive panes is given approximately by that function, where P of n is the percent of light, and n is the number of panes. So, hold on a minute. I can take a snapshot of what my screen is, and then I can write on it, which is kind of nice, actually.
Mm-hmm.
So what they want to know is, for question A, what is P of 10?
Mm-hmm.
How do I get to P of 10?
Don't you just sub in the 10 for n?
Exactly. In other words, whatever's in the parentheses, you substitute in for the variable. And the only variable here is n. E is not a variable. It is a number. It's 2.71. It's like pi.
Mm-hmm.
It's not a variable. Okay? So P of 10, I'm going to substitute 10 for n. Now, that number you need to get out of your calculator.
Mm-hmm.
Can you do that?
Mm-hmm.
Okay.
Okay, so I got 74.0818.
So that was 100 over e to the 0.3, which is like the third root of e. All right, I can believe that answer. That answer makes sense. Always like to do a ballpark check, if you know what I mean by that.
Mm-hmm.
What percent of light will pass through 25 panes?
Don't you just do the same thing?
Yep, except
25.
use 25 instead of 10. And the one thing we should certainly find is that it is less, right?
Mm-hmm.
Okay, so if you get a number greater than 74, we've made a mistake.
Okay.
That's another ballpark check.
So I got 47.2367.
Makes sense. They don't really indicate how many decimal places you need to give your answer to. Is there a standard in your class?
Just like 2.
2?
Mm-hmm.
So this was what? 47.23 what?
67.
So that actually, if we're going to use 2 decimal places, we got to round it off to 4.
Mm-hmm.
All right. Let's take a look at number 62. Now, notice that all of these look hard, but they're not really. They're just describing a function. There's the function right there.
Mm-hmm.
There's only one variable in that function. What is it?
H.
Okay. So when they say find the atmospheric pressure at a height of 2 kilograms, what you're solving for is P of 2,
Mm-hmm.
which is what? 760 times what? Read the rest of it.
E to the power of, what is it? Negative 0.145 times 2. And then that, I got 568.68.
I'm going to trust your calculator. I'm not doing these with you.
Okay.
So I don't know. I would say that if you think your teacher wants you to round it off to 2 digits, then you should always give 3 digits
Okay.
because you can't go wrong. In other words, if you give this and discover that she really wants you to round it off to 2 digits, you don't know if that 8 is correct or not, right?
Mm-hmm.
Might be a 9. So if you always give 3 digits, you can always go back and figure out for sure what 2 digits are.
Mm-hmm. So the third digit would just be 0.
Okay, good. That tells you that you know the answer is 0.68.
Mm-hmm.
Even if it's 3 digits, it's, well, different story. But, all right. What is it, the pressure at a height of 10 kilometers? Not quite sure why they're giving you these pieces of information.
Mm-hmm. I guess just to trip people up.
Kinda. In other words, they're completely irrelevant. We're solving for kilometers in both cases. In the first case, it's 2 kilometers. In the second case, it's 10 kilometers. So my answer is going to be P of what?
10.
Simple as that. The rest of it is a calculator problem. You put in 10 instead of 2 right there.
Mm-hmm. I got 178.273.
Now, does that answer make sense? At 2 kilometers, the pressure was, what was it? Do you remember?
568.
Okay. Now, is the pressure, should it be greater or less as we go higher?
Less?
Yep, and it is. It's 178. Again, that's what I call a ballpark check. Sometimes a ballpark check is just seeing whether it should be greater or less than. Other times a ballpark check might be, are we correct within a factor of 10? Because
Mm-hmm.
usually when people make mistakes, it's by a factor of 10. You end up with an answer of 20 instead of 200 or 20 instead of 2. So most of my ballpark checks are factors of 10. But in this case, the best ballpark check is to just make sure that we know the pressure decreases with increasing height. That's what it says right there.
Mm-hmm.
Decreases with increasing height. Well, we've gone up by a factor of 5. It doesn't necessarily mean the pressure is going to go down by a factor of 5, but it definitely is going to go down. So we know this number P of 10 cannot be greater than P of 2. That was P of 2. All right. What else?
Let me send you another one.
Okay. And if you're sending these pictures in real time, send just one at a time. If you send like 5 pictures at once, it's instead of going to take 15 seconds, it's going to take 5 minutes.
Okay.
It's like exponentially greater, the amount of time it takes as you add images to what you're sending. So if you want me to get it quickly, send one image only. And then while we're working on that problem, you can maybe send the next 2 or 3, depending on how many you think we'll get to in this session. We still got 20 minutes, so I'm not sure. Okay, I got that one. And again, let me download it so that I can rotate it.
It was all 4 of these.
Okay. You might want to not use the flash. Notice that what happens when you use your flash. It creates this spot on the picture that's almost not readable. I actually can read that, but I can tell you used a flash. Better, am I correct? Did you use a flash?
No, it's just there's a bright window.
Oh, okay. I was going to say the best way to take these pictures is to just find good, strong, consistent light and take it under that light. The flash generally creates this place in the picture where you can't read it because the flash is too bright. All right, so we doing 64?
Yes.
Or 65? You tell me.
We're going to do 64 through 67.
Okay, that's right. You said all 4 of them. Well, probably not going to get all 4 of them done, but let's have a look at it.
Okay.
All right. So this is the area of the wound with time, n being the number of days after the wound. So would you expect this to get smaller or bigger?
Probably smaller.
Yeah, I would hope so. Otherwise, you're looking at amputation. Okay. So if a wound initially had an area of 100 square millimeters, what is that in the formula?
Isn't that A?
It's A sub 0. In other words, this, hold on a second. I keep forgetting I have to take a screenshot here. A of n is the area of the wound after n days. So we know as n goes up, the area of the wound's got to go down. A sub 0 is the initial area of the wound. Whenever they put that very first number there, that's the initial amount you're depositing in your bank account, or it's the price of your new car, but it's the initial something. Well, that's 100. Now, I'm going to just put the units on there to make sure we don't get... In other words, sometimes they can try to make these tougher by switching the units. You don't always need units. If it's an easy problem, you're not going to need to put the units in there, but if they make it a particularly difficult problem, they may give us something in square meters, in which case we'd have to convert. But in this case, I don't think we do. Okay, so that's A sub 0. we're multiplying it by e to the minus 0.35 number a.
All right.
What am I substituting for n?
3.
So that's a of 3, and that's going to be that. So we're not going to need units because our answer is going to come out to be square millimeters. So I don't really need to pay any attention to that, although it's useful to know that our answer isn't in square meters. Certainly wouldn't want a wound that was in square meters, right?
Yeah.
Okay, so substitute 3 for n. Again, use your calculator. What do you get?
I got 34.993 or 994.
Like I said, she doesn't give any directions on any of these as to how many decimal places she wants. So always put as many down as you, always put one more down than what you think she wants.
Okay.
If you think she wants to the hundredths place, then put 3 down. If you think she might want to the thousandths place, then you need to put 4 down because we don't know if that 4 is correct. It could be a 5. So it all depends on what she's asking for in terms of how many decimals.
Okay.
And again, question B is not difficult. It's just the same problem, only with 10 instead of 3.
Mm-hmm.
So let's go on. I know you know how to do that.
The next one?
Well, no, I know you know how to do 64B. So let's not spend our time on 64B. 64B is just plugging in 10 instead of 3.
Okay.
It's not any kind of a difficult problem. So make sure, because we only have half an hour today, I'd like to get as far through these as we can. All of these are really, really straightforward. There's nothing tough about any of them. How do I figure out this one?
Which one?
Yeah, I'm sorry.
That one?
Huh? What is that? D of what?
1.
Correct. So D of 1, which is equal to what?
5e to the power of negative 0.4 times 1.
Incidentally, I don't know why I have this conversation with everybody, but I don't know why they put that 0 in there. Completely unnecessary.
Mm-hmm.
You agree?
Yeah.
I mean, why put figures that are completely unnecessary? It's like putting a 1 in front of x. It's not needed. Just extra writing.
Mm-hmm.
If I put 0.4, that means 0.4. So I'm never understood why Colorado high schools do that, but they all do it. You along with 98% of my students, always lead with that 0. And to me, it's a waste of breath. Okay? It's like, I don't need to put that 1 there either. And that's the answer. And the answer to this part, what is that? D of what? That's D of what?
6.
Correct. So D of 6 is you're just going to substitute 6 wherever you see H.
Mm-hmm.
Again, you're getting those numbers out of your calculator. I'm just going to trust you know how to do that. It looks like you do. I'm not checking it.
Okay.
Okay. I suspect you're pretty good with that calculator. Right?
Yeah.
I thought so. That's not something I need to check. In other words, the key on all of these is setting it up. Let's see if we can find a little tougher one. Jesus, all of these are really easy.
Mm-hmm. Okay, I can
And
see.
notice here we got two variables. We got P and we got D.
Mm-hmm.
Huh. Well, they gave us both of them. So what is N equal to?
1000 times, or in parentheses, 1 minus e to the power of negative 0.15 times 3.
Yep. Again, calculator problem. Now this calculator problem, you have an Inspire, right?
Mm-hmm.
Well, the beauty of the Inspire is when you put something in, it gives you its visual representation back. So you can know whether you're putting in correctly, as opposed to the previous generation calculator, the TI-84. It just had a bunch of parentheses. And you can imagine if you had to enter that with strictly parentheses, it might be a little tough. But as long as the Inspire shows you exactly what you're entering, then there really shouldn't be any problems in coming up with this answer. What do you get?
Mm-hmm. What'd I get?
Uh-huh.
I got 362.3718.
0.37?
0.3718.
Okay. Well, the only reason I ask is that obviously you can't have 0.3 of a person,
Mm-hmm.
and this is a population. So I guess you have to round down. 362.
Mm-hmm.
In other words, this one kind of gives you, well, they aren't specific about it. So I'm going to say the answer should be 362, not 362.37.
Mm-hmm.
Okay? Because you can't have a part of a person. Now, does that make sense? What if our answer would have been greater than 1,000?
Well, there's only 1,000 people, so.
Exactly. So it couldn't have been right. So what I look for in terms of a ballpark figure here is at least make sure we're less than 1,000 in our answer. I mean, when you're inputting stuff like that into your calculator, it's so easy to make a mistake that can make you off by a factor of 100. You know, just by excluding the negative sign there, you're going to get a completely different answer. So when I say a ballpark figure with this question, it better be less than 1,000. If we get any answer greater than 1,000, we've made a big mistake.
Mm-hmm.
So you want to look for those kind of things. Okay. Do not be intimidated by all of this complicated talk. Seriously. In other words, they're giving you the formula you need to know. It's not like they're saying, give me the formula. You don't need to give them the formula. They're giving it to you.
Mm-hmm.
And that's always going to be the case, at least at this level. Once you get into calculus, you may have to come up with the formula. But they're giving you the formula. So it should be a matter of plugging in. And that's the probability, f of t. I don't know why they call it f of t. They should call it p of t. But it's the probability. The following formula can be used to determine the probability that a car will arrive within t minutes of 12 o'clock. So what's the probability that a car will arrive within 10 minutes of 12 o'clock? What is that going to be? F of what?
Is it just 10?
Now, the only thing we have to be a little careful with here is to make sure that everything is in the same units. And it isn't always. But if we read through the problem, that's per minute, that's t minutes. Everything appears to be in minutes. Nothing is in hours. So we're fine using 10. And then whatever that is, what is that number?
Got
Curious?
0.63.
0.63?
Mm-hmm.
And that is a probability answer. So we're going to need more digits on that because that's 63% probability. Okay, so they're going to want more digits than just 63% probability. Was there more digits after that?
Mm-hmm.
What are they?
2121.
I don't know how many digits she's going to want, but that is 63.2121%. So if she wants it to the nearest hundredths, you're going to need that 2-1.
Mm-hmm.
Now, so let's look at this problem. Let's just talk about it for a minute. What they're saying is that between 12 and 1, they're introducing you to calculus incidentally here. Between 12 and 1, we should get 6 cars per hour.
Mm-hmm.
So the probability that a car shows up in the first 10 minutes should be relatively high.
Mm-hmm.
In other words, if everything was linear, we'd get a car every 10 minutes, right?
Yes.
Well, they're saying, what's the probability of a car arriving in the first 10 minutes? And we're getting 63%. Well, that's not 100%, but it's still more than half. So that's in the ballpark. That makes sense. Now, determine the probability that a car will arrive within 40 minutes. What's that? F of what?
40.
Gonna let you do that on your own.
Okay.
Let me see what the next part of this question is. I know you know how to do that part. Graph F using your graphing utility. You know how to graph that?
I think so.
I'll tell you what. We don't have much time. This the last problem? Yeah. We only got one more problem, right? Part D.
Mm-hmm.
Go ahead and graph it on your graphing utility, and I'm going to graph it on my graphing utility, which I use Wolfram Alpha. Have you ever heard of it?
Mm-hmm.
It's a great program for any kind of math that you want to do. Especially for me, where I'm doing a lot of stuff online. Hold on a second. I do have to find the function, though. So, if I graph y equals 1 minus e raised to the negative 1x. Notice that I use x instead of t. Doesn't matter.
Mm-hmm.
The key thing is on Wolfram Alpha, it's going to tell me what I put in. I obviously didn't put it in correctly. 1 minus e raised to the negative 0.1 x. Not sure how that period got in front of there. I don't know if that matters or not, but it sure didn't give me what. There we go.
There you go.
It did matter. That extra period screwed everything up. But the beauty of Wolfram Alpha is it tells you exactly what your input is. So you can really be certain that you've put it in correctly. And the Inspire kind of does that also. So you can certainly do this on the Inspire. Okay. Now, if we look at that last question, so we've done part C, graph F using your graphing utility. What value does F approach as t becomes unbounded in the positive direction? It's not absolutely clear from this graph.
Mm-hmm.
Kind of have to think about it in algebra terms. What happens to e to the minus 0.1x as x goes to infinity? What does that approach?
For the y value?
No, just this part right here. I'm going to take a picture of it. Sorry for holding you longer, but I think it's worth finishing this problem. This part right here. What does that go to when, in other words, minus 0.1 times a million? What happens to that whole thing? Does it get big or does it get small?
I think it just gets closer to 1.
It gets closer to 0. That's the same thing as 1 over e to the 0.1 times a million, which is 1 over a very big number. So it's like 1 over a million.
Mm-hmm.
Well, that gets very, very tiny. That's 0.0000001. Okay? So whenever you have a negative exponent for e, and this thing, the exponent approaches large numbers, you know it's going to 0. So if this part is headed towards 0 as x approaches unbounded in the positive direction, what does y go to?
Is that the one that comes closer to 1? Because that's what it looks like on my
It goes
graph.
closer to 1. In other words, it's 1 minus 0.
Mm-hmm.
And that is your introduction to limits. Seriously. And it's about the time of year where you're going to start getting calculus. You're in honors pre-calc trig, right?
Just regular pre-calc.
Just regular pre-calc trig. You're still going to get some calculus stuff. You may not get a whole lot because you still got trig to go through. But this stuff, the difference between calculus and every math that comes before it is limits. When you're dealing with limits, you are dealing with calculus. And this problem, the fourth part of it, when it talks about t becoming unbounded, you're talking about limits.
Okay.
Sam, I'm going to let you go. Let's see, when you logged in to go to meeting, did you put down your email address?
It didn't have me log in or anything.
What is your email address?
I think you can just grab it from the email I sent you.
Okay. Yeah, that's right. I forgot. You did send it to me an email. Okay. What I do is when I get this file processed and a recording made of it, I send you an email telling you how to see it, how to find the link for it. And the link's always the same, so I only send that email out once. But every time after that, you can always find the recording if you need it. You won't always need it, but sometimes you might. And it's quite useful if you do need it. All right?
Okay.
Sam, I will talk to you next time. The way you log out is just to click on the X of your GoToMeeting panel.